Hi everyone, thanks for tuning in. I'm India Block, US editor of Dezeen, and I'm joined today by Chris Harrop, who is the sustainability director of Marshalls, and he's going to talk to us about how we might be able to build sustainably with concrete brick. Hi Chris.
Hi everybody.
How are you today?
Very good. I'm delighted that the weather has turned nicer in the UK. So yes.
Yeah, no, it's a hot day here in London.
Yeah, I'm looking forward to talking to everybody about building sustainably. It's something I'm
Yeah,
very passionate about. I've been talking about this for over 20 years. It's great to be able to share as widely as we can now.
and great. Could you introduce yourself to our audience?
So, hello everybody. I'm Chris Harrop. I'm Director of Sustainability for Marshalls PLC. I've been at Marshalls best part of 20 years, and over that time, I've led on the various issues of sustainability. So whether that be climate change, I put our first carbon report out in 2004. Product carbon footprinting. We were Pathfinder with the Carbon Trust in 2008. The whole ethical sourcing and ethical trading work that we've been doing, plastics, packaging, natural capital, biodiversity, all of that falls within my remit. So today I want to kind of share with you some approaches, some things to look for, some ideas, and some ways of reducing climate change through really good building and design.
That sounds great, Chris. And I believe you've got a presentation to share with us to kick things off.
Yeah, if I could just share with you just a few slides just to get us going in our discussions. Really, this is not a Marshall sell. This is more about what to look for in starting to really drive out embodied carbon from all the buildings we do, recognizing that what we do now will have a massive impact for tens of years, up to 100, 150 years into the future. So I think probably a good place to start is a little bit of history, but as Marshalls, Marshall started in the 1880s with Solomon Marshall in a quarry in Yorkshire in the UK, and all through the years it's been around stone, concrete, and a full range of building materials. And if I can share with you with a bit of caution, I'll use the BBC statement that they always use at this point. So this image has outdated attitudes, language, cultural depictions. So this I pulled this out of our archives. This image was taken in 1958, and it's showing a reconstituted York stone wall and swimming pool, although why there was a swimming pool in Solihull, which is exactly where this photo was taken, is slightly beyond me. But we've been in this market for a long time, and the point is we've been learning. And the next image you can see there, the Glenstone bricks, we believe that's 1972, and the only reason I can say that is the registration on that little mini Clubman. If anybody's a bit of a car geek, you'll notice that was 1972 as a reg plate, and there's a Ford Anglia in the bottom corner. So we've been talking and working through housing bricks and building bricks, as well as all the various landscaping and concrete, natural stone for a long time, starting with Solomon in the 1880s right the way through to today. Now, talking of today, some of the products, they do look absolutely stunning, and they one of the myths is that they look very different to a clay brick, and that's not the case. This is an amazing scheme. It was done by Carter Building Consultancy, I think based in Preston. This is in Poulton Field in Cumbria. Stunning piece of architecture and a really nice use of product. But I think what we really need to do is we need to actually give ourselves all a reality check when we talk about issues of sustainability, and in particular climate change. So I pulled this off, it's a couple of days ago now, so it's slightly worse now, but this is the time left till the Earth warming hits 1.5 degrees, and it's currently 11.5 years. So we really need to kind of get off the pot, agree with the science, it's happening, and start to make very, very significant changes at a corporate level, and then clearly at a project and product level. So, and anybody wants to go and look at that, that's the climate clock at the Human Impact Lab, climateclock.net, and you'll see it counting down. So with this issue of climate change, the models, or the mental models that I would have, is first thing you've got to do is prevent it. Well, I think actually that ship has sailed. We're now into issues of mitigation. What can we do to reduce the impact? At least hold it to 1.5, or probably more like 2, or well below 2, hopefully. And then move into adaptation. And we're seeing the absolute need for adaptation coming through at the moment with the floods in Germany and northern Belgium, and the fires and the heat dome that's happening on the west coast. But we need to move into an adaptation world, and all of that should then give us some resilience to cope with what is probably going to be at least a 1.5 degree future. And probably at the moment, if you take the projections and all the work that's been done out of the Paris Accord, probably more like 3 if we're not careful. Now, that means that all of us, especially in the built environment, we need to really take notice of this from an embodied and an in-use and product design perspective. So, moving forward a little bit on Marshalls and the way that I think about these things, it's, none of these things are in isolation. So we start off with, we've been UN Global Compact signatories since 2009, and that brings together human rights, labor rights, the environment, and issues of governance to make sure that things are done properly. And that leads us into where we see our role, and it is about sustainability and about creating better futures for everybody. And we say better futures for everybody, socially, environmentally, and economically. That leads us into our Marshall's Way, and this is the guiding light that works through all kind of 2,500 people in our business. We do the right things for the right reasons in the right way, and then certainly from an architect and design perspective, that leads into action, mainly around the sustainable development goals, but around decent work, around sustainable cities and communities, about responsible consumption and responsible production, and clearly climate action runs through all of that. So that's the frame, the mental model that I have within our business, and I kind of had for certainly the last 15 to 20 years. And one of the things that's really important going forward, because we've hit this tipping point now where people are really starting to take notice, we need to avoid greenwash like mad, and we need to avoid these statements around net zero by 2050, 2065. Because if you think back to that chart, the image I showed you of the 1.5 degree climate clock, 11.5 years, we need to be doing it now. So we set and have approved something called science-based target. Science-based Target Initiative was set up by UN Global Compact, Carbon Disclosure Project, the World Resources Institute, and WWF, and it is our fair share of removing and reducing our carbon footprint to hit that 1.5, well below 2 degree target. We've already reduced our carbon footprint between 2008 and 2018 by half, through a whole range of different things we might get into later, but we've now got a further 40% to take us down to that baseline by 2030. At a corporate level, that's fine, but it actually is at a product level. So I mentioned before product carbon footprints, been doing that since 2008, constantly reviewing them, and we work with the Carbon Trust to work on those carbon footprints, because it's about making sure that they are really solid, and we're not open to accusations that we've just made these numbers up. So using the best systems and accreditations and standards that are out there. And one of the really important things, I think, from an architect's and a designer's perspective, is knowing on what basis you are comparing a product footprint, because this embodied carbon is clearly a big issue going forward. And there are a couple of different ways of thinking about it. So the first is a cradle to gate. So a lot of EPDs, environmental product declarations at the moment, are using cradle to gate, and essentially that's everything, all the extraction, manufacturing, ready for delivery, installation, its use, and then its recycling at the end. So everything up to the gate, and then cradle to grave, which is the one that I would suggest is the more meaningful, you know, that's the important one, because that is everything from raw material all the way through to recycling at the end of the product's life and getting it ready to go back into a process. And that process could take 100 years or more. So cradle to grave is the one I would say. But, you know, really, when you're doing comparisons, just make sure you know you're comparing apples and apples, not apples and oranges. And the standard that I would suggest should be used on all materials is PAS 2050. We were part of the Pathfinder for that back in 2008, and it's, you know, it's a really good way of making sure that it, like I said, it is apples and apples. And from an embodied carbon perspective, you know, I'm clearly biased because I work for Marshalls and I've been driving this agenda for the best part of 20 years, like I said. But, you know, when you look at, you know, concrete bricks, which look like and feel like and install and lay and use and weather and, you know, color and all the other bits and pieces, all of this stuff, just exactly the same as any of the other kind of materials used for bricks, clay in particular. The cradle to gate number is that this brick is a third of a clay brick, and the cradle to grave is that this is about half, so 49.1% lower, using those methodologies and using the published data that's out there. And anybody that's designing schemes that also need water management, water systems in there, you know, when you look at the difference between concrete and plastics, you know, the reductions are even higher. And that's, you know, the important thing is really understanding the process, understanding the standard, and then doing an apples and apples comparison. And, you know, because certainly from my perspective, because I've been doing it for so long, we've got such a wealth of knowledge, experience and information to be able to make those comparisons, and also then to drive the number down and keep driving the number down. Last slide from me, really, before we kind of take some questions and have a discussion, India. But, you know, when we think about mitigation, and I put this in particularly with, you know, the issues around Germany and North Belgium at the moment, but we've certainly seen it in the UK, and we saw it in London just last week, flood water. You know, the biggest impact of climate change in the UK is clearly weather. So, you know, we're going to get warmer winters, we're going to get wetter summers, and when it does rain, it's going to rain with such more intensity. We're going to get less frost days, etc. I think it's about 86% less 0 days than historically that we would have had, certainly in the last 30 or 40 years. So we have a permeable paving product as one example, and I could have pulled out lots and lots of examples from a portfolio. But, you know, that the amount of permeable paving that we have installed in the estate already, having been doing this for kind of best part, you know, 15 years or so, it's about 625,000 cubic meters of water that is being prevented from flooding. And to put that in context, that's 1 billion pints of beer, or 8 million baths of water. But, you know, you can still drive a truck on it, drive a tank on it if you really wanted to. But we've got to think now about adaptation and use everything in our arsenal to adapt to this changing environment and this changing climate. So we've got to reduce embodied, because that's impacting on the manufacturing process and the amount of carbon that is emitted for its life in that envelope, in that building. And then we've got to use really good product design and scheme design to produce and to mitigate all of those impacts of climate change coming forward, whether that's hard or soft or the combination of both of them. So that's probably enough of kind of me kind of setting the scene for kind of where my head's at. You know, the reality is we've got to act now, and you know, no time to waste at all. India.
Thank you so much for that, Chris. I think you're quite right. It's quite scary every time you go on the news now. There's the floods, as you mentioned, the huge heat wave across the west coast of America. There was that flaming Gaia in the middle of the Gulf of Mexico. I just was on Twitter earlier and saw that drought has killed thousands of flamingos in Turkey. Could you kind of break down for us why is 2050 too late? It's a number that we hear a lot, but
yeah, I mean,
I really think it's far too late.
It is far too late. So, you know, I hesitate to say, you know, informed and driven by the science, because that's kind of becoming, certainly in the UK, a misused phrase. But, you know, the science is very clear. We have 11.5 years before we hit 1.5 degrees. And after that, you are into really big systemic changes. And it will impact on weather, it will impact on food production, massive impacts on migration. So that's the horizon we're looking at. So any targets for me, any target much past 2030, or 2032, are really missing the mark. And by 2050, if you look at the projections from the IPCC or some of the work that was done and is being done in the lead up to COP26, the new intergovernmental panel on climate change, you're seeing that without even more action now, we're going to easily hit 3 or even 3.5 degrees of warming. And that's going to have massive impacts on us all. And if you're living in the coast, you're going to have to really start to think about adaptation and how you're going to cope with a rising sea level and increased rainfall.
And the history of marshals, they've clearly been working with stone for decades now. But if you approach someone on the street, I feel that, and you ask them, is clay better or is concrete better? Concrete's been getting such a bad rap in the industry press, in the national press, in the international press. Could you break down for us why you find that building with concrete is actually more sustainable than building with a clay?
Yeah, I mean, there's a couple of things. I mean, probably the fundamental is a misunderstanding or an interchangeability, certainly in some commentators' minds, between cement and concrete. And cement is only one part of concrete, and there's been a lot of work over the years in terms of cement substitutes and cement replacements. So certainly from the R&D work that we've been doing, and we've got an amazing technical team behind me at Marshalls, but we've removed 60% of the cement from our products certainly over the last 10 years, without affecting its strength clearly or its performance, because the products have still got to last 100 and something years, and it's the mix. So of that proportion of concrete, a smaller proportion is cement, and you can reduce the cement and use substitutes, certainly much lower carbon substitutes. So we've got a mindset we've got to address. But also I think once you start to get into the data and into the science and really start to understand the cradle to grave impact of products, certainly from a concrete versus clay perspective, we don't need to fire the product out hundreds and thousands of degrees for that period of time to cure it. I mean, the concrete product will almost cure naturally on its own without any additional help, and will just get stronger over time. And in fact, actually, over the course of its life, given the chemistry, actually starts to reabsorb some CO2. And it's about 19% of the CO2 is reabsorbed over the life of the product. So there's some education that we clearly need to do. But I think fundamentally, we need to start breaking the cement and concrete differentiation.
That's really interesting, because I wouldn't have known that. And my next question was going to be, what's your reaction to the news that Sweden has just closed its biggest cement factory? Is that a concern, or would you welcome that if you're trying to move away from cement?
Yeah, I think why do we use cement? Well, we use cement because actually it's a really good building material, and it can be really effective. And from a places perspective and a place making and a built environment perspective, it can produce some absolutely amazing, fantastic buildings and spaces. The work we've got to do is to reduce its impact right the way down to this net zero, to as low as humanly possible over a course. So the cement companies themselves have got a lot of work to do to reduce the impact, and then potentially start thinking about carbon capture and storage and taking the CO2 out of the pipe as it's being produced and potentially storing it. And then the manufacturers of concrete have got to be really smart and cute about the use of cement substitutes. So, we have this debate. It's a bit like the debate on plastics, isn't it? So, is plastic the problem per se, or is it what we do with plastic and how we recycle it that is the problem? And I think it's probably more about us and our behavior than the fundamental problem of the plastic, because without plastic, food waste across the world will just explode. And we've only just about in balance across the world with having enough food to feed ourselves. So it's usage, isn't it? And doing everything possible to reduce that carbon footprint.
And this cradle to grave system as well, that's kind of part of making sure that you're not treating construction materials as disposable, because I think especially with a lot of the kind of mid-century concrete buildings coming down right about now, people are kind of asking questions about whether one should keep a building up or whether one should try and adapt it. How does the cradle to grave process work? Would you take material back from your suppliers, from your clients? What happens to a concrete brick was made by Marshalls and it served its purpose? How does it kind of get fed back into that loop?
I mean, one of the beauties of these products they are basically 100% recyclable. So that taken and crushed can go back into a concrete production process without hardly any problems whatsoever, because it's a known entity. I think the challenge for the sector is about getting the products in a recyclable form that can be used. I mean, we've all seen construction sites where waste isn't segregated, waste is mixed, and ultimately, you're making it kind of a little bit unusable. If you're mixing different materials, whether it's glass or potentially some plastics, clays, stones, concretes, whatever it will be, the thing you need to have a functioning product is reliability around strength, isn't it? Because you're building something that's got to last at least 100 years. You want to have that reassurance. So as long as we can start to have really clean, clear waste streams, there's absolutely no reason why this can't get crushed at the end of its life and go back into a product and reused again. And at that point, this concept of the circular economy really starts to come alive. And there's lots of material gets reused at the moment, but is it all getting reused? I still go to sites and I still walk past skips from kind of builders where the material inside is so mixed and so almost polluted that it's really difficult to get those clean waste streams to go back into the production process. So as a sector, we have that challenge, don't we?
And the carbon that the bricks are kind of absorbing over the course of their lifetime, when that's crushed and remade into something, is the carbon released, or is that kind of trapped forever within the aggregate?
Once that has been reabsorbed, sequestered, once it's been reabsorbed, it's now a solid, and that solid remains a solid. So when it goes back into a new product, it's basically another piece of powder, granule, aggregate that then gets bound back into the product to get used again. It certainly won't absorb anymore. It's done its piece, but the rest of the activation from the cement or from some of the other additives will do the next bit of sequestration. So it's locked.
Mm-hmm. And you mentioned kind of site visits and people not kind of 100% being there when it comes to separating waste. And as you said, we've sailed right past prevention. We're into the mitigation stage. Do you think the built environment industry is ready to make this change? You've been banging this drum for a while. Are people listening, or are people still not quite there yet?
I think the great thing is, things are changing. Sometimes it takes tipping points, doesn't it? The public awareness of plastics, came from the Blue Planet moment. The awareness and really the big push on climate change came from, that amazing teenager Greta Thunberg. We're now having those debates. If you look at some of the research, certainly the consumer research, consumers are making really big active choices on the basis of environmental performance of products now, and that's seeping through. Our behavior as individuals and our behavior at work is very much intertwined. So people are really now starting to pay attention and to ask questions. My play is to ask the right question and the right standard. But as a sector, we've got to move really quickly, because the products that we produce and the schemes and the buildings and the built environment we create lasts a long time. So we've really got to get on with it.
Well, it's interesting you should mention the right questions. I'd be super keen to hear what those questions are. As Dezeen, we're very against greenwashing. How can people spot that? You know, how could clients looking to build something, how can they know that, you know, a company is using greenwashing language? How can architects looking for a product, what are the kind of big tells?
So, I mean, the first big tell is that there's a statement without actually stating which standard was used to create the number in the first place. And, you know, the next bit from that is, have you ever heard of that standard? Is it an internationally recognized standard? Is it an ISO, or is it in the UK a BRE standard or a carbon trust driven piece of work? So, and I've seen lots of kind of marketing literature recently, as I'm sure most people have, with grandiose statements about net zero and some carbon free and carbon neutral. So what's the basis? What standard? And what's the basis for doing that? And then the other kind of, you know, pet peeves I have around greenwash is, you know, I have a product. So, you know, here is my low carbon product. And the other 2,500 products, they can continue being awful, but I have a product, it's my flagship product. Well, I don't think that's good enough anymore. If you've got 11 and a half years, everything needs to be as low carbon as you can possibly make it, and ultimately from an architect perspective specify. So it isn't just one product, it's got to be at a range level. And then the next one is to make sure it, you know, whatever that green claim is meaningful. So I was talking to someone the other day, and they were saying, well, wasn't it great that Branson went into space on Virgin Galactic? You know, absolutely amazing, fantastic. You know, did you see he even cycled to the launch pad to keep the carbon footprint down? Well, actually, Branson's cycling at half a mile from the car park to the launch pad is nothing compared to that rocket going up to the edge of the atmosphere, to the edge of space. So, you know, is that one thing that people are chomping about? Is that really meaningful? Or is it just, I'm using a cycle rather than actually tackling the big stuff? I could go on and on about kind of greenwash for a long time. It's one of my pet hates. But, you know, what is the standard? And where's the validation for that standard? Because otherwise people can just say anything. You know, what does actually low carbon mean? What does eco mean? You know, it's got to be backed by, this is the carbon footprint, it's being created using past 2050, and we've worked with the Carbon Trust or another recognized reputable organization to calculate this number.
And the irony being that even carbon footprints are bought in by the oil companies. Yeah, billionaires launching themselves into space is not really getting us anywhere closer to averting climate disaster. But I'm sure viewers at home have spotted the flag behind you. Could you tell us a bit about your trip to the North Pole and what you saw there?
Yeah, so this is actually my actual flag. I took this to the North Pole in 2017 and planted it at 90 degrees north. It took me quite a while to find it because the ice actually moves. So as soon as you get it and you start to plant your flag, the current moved you a bit. But I went there because I wanted to see the reality of kind of the impact of climate change as well as, let's be honest, an adventure, which it certainly was. But the reality was at the North Pole, even in 2017, the ice was 2 meters thick. That's all it was. And I was there in April, 13th of April, and that was all it was. And the amount of broken ice around was just frightening. Now, you know, that's really significant because white clearly reflects, and you know we can get into kind of issues of urban heat islands and as part of mitigation, solar reflectivity. But you know, once you get open water, that dark water will absorb more heat, which means it will melt more ice, which means that we'll have more open water, which means it will melt more ice, and which will start to shift and change the currents and the Gulf Stream and start to make this, you know, almost this spin-off of kind of climate change, possibly unstoppable if we don't start to do something about it. But you know, it was a fantastic, amazing. It was a privilege to be able to kind of get myself there. But really, it just brought home to me that we haven't got that long. And you know, 2 meters. I mean, you know, that ice should be tens of meters thick, even in April.
Yeah, that's terrifying. And especially now that, they're turning it into a shipping route, we're just accelerating it even more. And I read an article somewhere that it's not just the loss of ice and snow cover we have to worry about. If we get too far into a feedback loop, we'll lose cloud cover. And that's another big way of reflecting the heat back. And then if we lose all the clouds, then we are really, really screwed. You mentioned urban heat islands a couple of times. Could you talk a bit more about that and kind of ways that the environment industry can mitigate that? I know that we've got kind of white pavements, white paint coming up. Are those useful? Are they good? Or
Yeah, I mean, I think this is all part of an integrated mitigation strategy, isn't it? So it's about good design, it's about integration of green spaces, but it is also about products with really low SRI, solar reflectivity indexes. But there's a practicality as well. If you start painting all of the streets with very reflective white paint, there's a maintenance issue, there's a practicality, there's a digging up issue, there's all sorts of other things. So it's about choosing the products and where you put the products, and then making sure that they're practical. But we're seeing it. It's certainly the West Coast. Some of the cities in the West Coast have never had, for 100 and something years, or ever had 40-degree heats. And you just get a dreadful feedback loop because it's so hot. People run their AC more, which pumps out more heat into the environment, which means that they need to put the AC on more, and you're in this horrible loop. But fundamentally, what you want is a lighter possible product, and the product with as much reflective surface on it. So what you absolutely don't want is absolutely flat black, because that will absorb the absolute maximum heat. But then you've got the practicality, the other end of white. So we need to be really careful. I mean, one of the really good things about concrete, of course, is that you can have very light grey and white bricks without a problem at all, because we're talking about the aggregate and the binders that go with it. So I think I've got my white bricks are downstairs, but the light coloured bricks are really good for keeping the environment cool. And we will get to see that in the UK. Probably not to the extreme of the West Coast, but certainly Finland at the moment is having record temperatures, Moscow record temperatures. We've got to pay attention to these things. And so manufacturers have to respond, but then architects have really got to think about that place and about making that place resilient and adapted to this change.
That's very true. And you kind of showed us that triangle of Marshall's kind of pyramid of values. What is it that is important about the human side? I know that you've been quite involved in human rights issues. Could you kind of explain to people what those are around the concrete industry, and why it's important to not just focus on the environment, but focus on the human elements?
Yeah, I mean, I've been talking about human rights, child labour, modern slavery for a long time. All the work that I've been doing in India and in supply chains in the UK, and construction, unfortunately, is one of the global bad boys of modern slavery. It's in the top 3 worst offenders. Whether that be at the manufacturing or in the construction phase. So we need to understand issues of modern slavery and kind of human rights all the way through. But so we have a supply chain issue to look at in the UK and in international supply chains. But ultimately, what's the point of this? The point of this is actually to build something for somebody to inhabit or to use or to enjoy or to work within. So the coming together now of human rights and environmental rights is starting to really gain traction. And when you see the impact of climate change, it affects people, and therefore it affects their rights. So if you're flooded, that your human right to a safe, secure place to live and to build, create a family and enjoy life with your friends and relatives, that is being destroyed by some of these environmental changes. So the linking together, and at a global level, certainly the work, the impact of environmental and climate change is going to drive food insecurity. It's certainly going to drive migration, and whenever there is migration, there's organised gangs and organised criminals who will start to push more modern slavery and slave labour, and making those kind of human and labour rights abuses worse, because people start to get desperate. Now we potentially think we're a bit immune in the UK or in the Western world, but that's just not the case. We have products that potentially are touched by modern slavery. I think every single one of us has probably got a product that has been touched by modern slavery, and we need to move away from that. Certainly, I spend a lot of time thinking about all of our supply chains and making sure that we're as toxic as possible to modern slavery and organised crime. But if we don't address climate change, we're going to make those issues of human rights and labour abuses much worse, because we're driving problems into society through the work that we do, through the impact of climate change, and our work has to be to stop that.
And how do you check a supply chain? So I think that's another thing. I mean, I don't know if greenwashing is the right word, but we've certainly seen with the fashion industry that, after the factory collapse, a lot of brands said that they'd clean up their act, but in practice, it's proved very difficult, and things are being kind of contracted out with your industry. How can you mentioned making your supply chain toxic. What do you do to kind of deter that sort of?
I think to set these things in context, so the reality is, from a Marshall's perspective, 97-98% of everything we manufacture is manufactured in the UK with a very clear and well-defined supply chain. So we know exactly where the sand, cement, the aggregates, the pigments, etc. come from, exactly where it's produced, and exactly how it's transported. So that's a very visible supply chain, and that links through to things like the 6001 responsible sourcing accreditations that we've had for years, and give people reassurance that that's responsibly sourced. It also moves us then into the other accreditations like 6002, the BRE ethical labour standard, which makes sure that that supply chain is mapped. So all the raw materials from start to us and beyond, what is it all? What's the map look like? And then where are the risks and what is happening? So who is doing the transport? So if it's materials coming in from overseas, where's the raw material come from? Where's the transport to the factories, to the production in the factories, the shipping to the port, the ship itself, and the labour on that ship, because there's quite a lot of issues for kind of shipping labour. But the reality certainly for this and for these kind of products, because they are very efficiently made in the UK, we have a lot more understanding and control. And then you use something like the BRE 6001 and 6002 to give the assurance that the processes I'm driving through and my business and human rights director Elaine is pushing through really are there and come alive and make a difference.
And sand, I know, is another one of these kind of areas that's got a huge ecological impact, a huge human impact. It's been literally starting wars in some places. Where does Marshall's get its sand from? So
the UK material, it comes from the UK. So it's from the UK, and more we're looking at different materials, different sources. Certainly, if you think about these circular economy, recycled approaches, you can recreate the angular nature of the sand that you need to go into these materials. We have some trial machinery that we're using, which will take pulverized glass bottles and turn them into bedding sand for kind of under pavements or under buildings, where the issues can be resolved around sort of silicate reactions, etc., around concrete. But we're doing that very quietly to do proof of concept, rather than do the greenwash that says, oh, all of our sand is recycled. We're doing it quietly, make sure we can do it, and then do it at scale, and then talk to everybody about it. So watch this space in terms of more work on recycled content coming in the future. But certainly this UK produced, UK raw materials, UK labour, UK factories with an assurity around it.
And you mentioned this anti-flooding material that you've been developing. Could you tell us a bit more about that? Because that is definitely something that the UK is going to be facing a huge problem with, especially as we're trying to avoid our housing crisis by building on more of our land. How can architects and urban planners?
Yeah, I mean, permeable paving as a concept is reasonably well understood. I think there are a few myths around it that it gets clogged up, but we've got some videos and some work that some of the experts. I've got a brilliant guy called Chris Griffiths who leads on our product sustainability. He's been championing suds for many years. The product itself works incredibly well. It's very, very well engineered. It will take typically 10 centimeters of flood water from the top into the sub base if it's installed correctly, and mitigate the impact of that flooding. But it also then has to work in conjunction with everything else. So it has to work in conjunction with the drainage channels, and it has to work in conjunction with the pipe work and the soft landscaping and the swales and the other areas of biodiversity. So it's a mindset about building in permeability and flood management, but also being really clear and careful about where you do it. If you're on a floodplain, you need to really start to think about things in a really heavy duty way. And in general, if you look at some of the models that we use and architects and engineers use for the 100-year storm or the 50-year storm, well, the 50-year storm is probably now the 10-year storm. The level of rainfall we're hitting and the variability and the extreme nature of some of our rain means that we have to beef up a lot of those products and a lot of the installations. So, crudely, making sure that the pipes are greater diameter, that the drainage channels are deeper, that the permeable paving sub-bases are absolutely fit for purpose, and that we've got the right capacity in the soft areas and the swales and the ponds that we need.
There's really no part of design that can remain untouched by this if we're going to address it. I mean, I guess kind of my last big question to you, Chris, would be, can we build our way out of a climate disaster? Is it possible by making more that we can achieve less?
I wouldn't. Let's just say instead of building out, let's just say building right. So, by making the right choices now, we are preventing a lot of carbon being emitted. So we can make some very significant changes now to hit the 2030 1.5 degrees. If we could do that through eliminating that carbon through manufacturing processes and through construction processes, we can do a huge amount now through changing the way that we think about products and building and projects to eliminate that carbon. And then, of course, what the residual, we need to find ways of removing it. I mean, I hate to say the offsetting word, but clearly we need to plant a lot more trees for all sorts of natural capital biodiversity reasons, but we mustn't be seduced into thinking that just planting trees will negate any impacts of kind of building or climate change. So I think we can massively improve. As a construction sector since 1990, when everybody's been aware of these things and everybody's been talking about bringing it down, as a sector in the UK, the total carbon footprint for the UK went up by 53% in a time when it should have been coming down. So we have to make some really big changes now. So, if it's as simple as switching from a clay brick to a concrete brick that's got the same aesthetic, the same function, but half the carbon footprint, to me, that seems like a no-brainer.
Yeah, you make a really good point. We've been covering a lot on Dezeen that just planting trees, especially if you're just planting little baby trees, is not going to get us out of it that much faster. Is Marshall's looking into, you mentioned carbon capture, are you looking into ways of kind of removing carbon from the atmosphere?
Yeah, I mean, I think by the very strictest best in class definitions of net zero, you need to reduce your emissions down to the 1.5 degree target by 2030, and then you need to find a way of permanently removing the residual carbon. Trees are possibly part of the solution, but only part. I mean, tree planting we do a lot of anyway because of the rectification for the quarries. But what you're doing is you're relying on that tree actually being planted if you're buying an offset. So will it get planted? Is it the right species? Some species that go into are, wrong for the environment, wrong for the country, wrong for the ground conditions. Will it actually grow? So, will it start to reach maturity? And it's actually only at about year 20 where there's some kind of neutrality for the planting of the tree in the first place. So is it going to stay without disease? Will it actually stay not being cut down? And then you've got to hope that it reaches its 100th year. And at its 100th year, that's when on average it's taken its ton. So there's a lot of variables in that. So the real interesting area for me is permanent carbon capture and storage. And there are emerging technologies, but they are emerging technologies. And there's a plant just gone live in Iceland, which is using geothermal energy to then power a plant that will suck CO2 out of the atmosphere, turn it to a solid, and then seal it away. But they are really expensive emerging technologies. So the job of all of us between now and 2030 is to make sure that embodied carbon is as low as absolutely possible, so that the residual to be removed is really small. Because I don't think from a carbon perspective we can rely on trees. I think we need to do a lot more tree planting and forestation for issues of biodiversity and natural capital, but certainly we shouldn't be solely relying on that for carbon and for combating climate change, because it's 100 years. That tree's got to be there 100 years before that ton's taken out.
Yeah, and we only have, what was it, 11 years to make change? Your climate calculator.
It's going to change. So when everybody's watching this video, it'll have changed by a day, but 11 and a half years today.
And I mean, it's stressful to think about these things. What do you do to kind of keep the panic at bay? Asking for a friend.
So what I do is I'm talking to our team every single day about new ways of that mitigation. So new ways of removing carbon and reducing carbon at a corporate level, at a factory, at a transport, at a raw material level, and then better products that to do adaptation. I want to have a whole range of products that move on, do this, take that embodied out, but then have those products that mitigate and help us adapt our way through this. So I keep saying, by pushing our team day in, day out to come up with both those areas, mitigation and adaptation.
Great, thanks so much, Chris. I mean, we've been going for kind of 50 minutes here, so it's probably time to wrap it up. But thank you so much for taking this time on a sunny day to sit indoors and talk about climate change with us. And thanks everyone at home for tuning in. I hope you found it interesting.
Thank you very much, everybody. So 11 and a half years, we've got to do it now, reducing embodied carbon and really focusing on mitigation. Thank you.